So we have looked at the definition of a gas, we have looked at the postulates of an ideal gas, and we have looked at the general properties of a gas. Now let's look at let's look at the definitions of this term. Number one, gas volume. What is gas volume? This is the space, taken to the word space, the gas occupies. And we said that space is dependent on the room you give it. So if you give it the whole room, it will take that space. If you give it the space of just a gas cylinder, it will take that space. So it is because of that is why it is dangerous when you on your gas. It might just fill the room, and once you leave your gas open, it fills the room, and you on your matches or your lighter. What happened? Explosion, because the gas has taken the space of the room. So what is the SI unit of volume? We say the SI unit of volume is what? Cubic meter. That is m raised to power 3. Take note, SI unit. You might not ask you in chemistry, but it might come out in physics. But don't be surprised if they still ask you in chemistry. But you should know the SI unit is what? Cubic meter. It will help you in physics too. Then, however, what we use in chemistry majorly is our dm cube and cm cube. That is cubic decimeter and cubic centimeter. They are the ones we commonly use. In fact, this is dm cube. We use it a lot in chemistry. You should take notes. And you take note that 1 dm cube is equal to 1000 cm cube, or 1 dm cube is also equal to 1 liter. So if you want to convert from dm cube to cm cube, you multiply by 1000. If you want to convert from cm cube to dm cube, you divide by 1000. I'll come again. If you want to convert from dm cube to cm cube, you multiply by 1000. But if you want to convert from cm cube to dm cube, you divide by 1000. The next is temperature. What is temperature? See, this is the degree of hotness or coldness of a body, and the SI unit is what? Kelvin. Take note, not degrees Celsius. Kelvin is the SI unit. I'm saying if you want to convert from Celsius to Kelvin, you add. So for example, 0 degrees Celsius to Kelvin, what do? You add, which is you add 273. So 0 plus 273, which is equal to 273 Kelvin. So 0 degrees C is 273 Kelvin. 273 Kelvin. Then if you want to convert from Kelvin to Celsius, you subtract 273 from Kelvin. So let's say you want to do 0 Kelvin to degrees centigrade. What do? You do your temperature in degrees Celsius will now be equal to 0 minus 273, which is equal to what? Minus 273 Kelvin. So minus 273 degrees Celsius. So from Kelvin to what? From Kelvin to degrees Celsius. So 0 Kelvin is equal to what? Equal to minus 273 degrees Celsius. So take note of this conversion. It is very important. From degrees Celsius to Kelvin, you add 273. You add 273. While from Kelvin to degrees Celsius, you subtract. The next is pressure. We say this is the force per unit area. It is a measure of the frequency, that is how often the molecules of a gas collide. It is the measure of the frequency, that is the frequency or how often the molecules of a gas collide with each other and the walls of the container. So the higher the molecules of the gas collide with each other, the higher the pressure. That is to say that if you reduce the volume, so the same number of gases that are here, you put them inside here, it will increase the frequency with which they collide. So in that case, you have increased the pressure. So you can see decreasing the volume has caused what? An increase in pressure, and that will lead us to what? Boyle's law as we go on. We say that what? At constant temperature, an increase in pressure will cause what? Or a decrease in volume will cause an increase in pressure. So look at that. Then the next is the SI. So the SI unit for pressure is Newton per meter square. Newton per square meter, or Newton per meter square. And this is the SI unit. Take note of all this SI unit. Like I said, they come out commonly. You can see it in your chemistry. But what we use commonly in chemistry is what? Our ATM, that is the atmosphere. So 1 ATM is equal to 760 milliliter mercury. 1 ATM is equal to 760 milliliter mercury, which is equal to 1.01 times 10 raised to power 5 Newton per meter square. So take note, most times they will not give you all this because it is a standard. You are supposed to know it, and so they will not give you this conversion, so you must know it for yourself. Then next we look at standard temperature and pressure. So the word standard is telling us that this is what labs use. This is the experimental condition you must obey when studying gases. So if you want to do any experiment on the gas, you must compare that experiment to the standard temperature. What happens at the standard temperature and pressure, which is what? The standard temperature is 273 Kelvin or 0 degrees Celsius. So like I told you, if you want to convert from what? From Kelvin to Celsius, you subtract. So if you do 270 minus 270, you get 0. So that is your standard temperature. Then your standard pressure is 1 atm, which is equivalent to 760 meter mercury, which is equivalent to what? 1.01 times 10 to the power 5 Newton per meter square. So having defined these terms now, let us apply them. And in the application, that is what we talk about the gas laws. So we're looking at gas laws. So for your gas laws, we start with the Boyle's law. Boyle's law. And what does the Boyle's law state? It states that the volume of a given mass of gas, the volume of a given mass of gas is inversely proportional. Is inversely proportional to the pressure if the temperature is constant. If the temperature is constant. So what this is simply telling is that what things you want to take note of here is the volume of a given mass. So of a given mass of gas is inversely proportional. Volume is inversely proportional to what? Pressure when temperature is constant. So you see those three things, these three words must be there. The volume is inversely proportional to the pressure when temperature is constant. So volume is what? Inversely proportional, which is 1 over P at what? At constant. So they say given mass of gas at constant mass and temperature. Mass and temperature. So what that simply means is that if you increase the volume, since it's inversely proportional, if you increase the volume, you what? You decrease, that means the pressure will decrease. So if you have 100 people in a room and you increase that volume, that is, instead of just making it one room, you now what? open space and now there is more than one room, what will happen? The pressure, that is the frequency with which they are hitting each other if they are walking in the room, will be reduced. So it's a very simple logic. So if you increase the volume, the pressure will be reduced. I would say pressure is due to what? The collision between the particles and the wall. So if you increase the volume, the pressure will reduce. And if you increase the pressure, what will happen? The volume will reduce. So if you increase the pressure, the volume will reduce. So that is what we mean by inversely proportional. But most times you can increase the volume and we are more in control of the volume. So if you decrease the volume, the pressure will increase also. So if you increase the volume, pressure will reduce, and if you decrease volume, pressure will increase. So if you have 100 people in a room that is normally spacious and you now reduce the room, you can see that as you reduce the room, the chances that when people are walking, they will be hitting each other more. So you can see, so collision will be occurring, and that is what we mean by pressure. So that is what inverse proportion is talking about. So now let's look at equation on that. Let's apply it. So we say a certain mass of gas of gas occupies 200 cm3 at 1.0 times 10 raised to the power 5 Newton per meter square. Take note of unit. Your unit should be consistent. You say calculate the volume when the pressure becomes 2.0 times 10 raised to the power 5 Newton meter square at constant. So take note, you can see they are telling that it is what at constant temperature. So this is telling you that this is Boyle's law. So what do you do? Solution. Always write out what you are given. So a certain mass of gas occupies 200 cm3. So what this means is that the initial volume is equal to 200 cm3, and let's call the initial volume V1. Your V1, then your V2, which is your final volume, is what we are looking for. Then your initial pressure P1 is equal to what? 1.0 times 10 raised to the power 5 Newton per meter square, while your final pressure is what? Your final pressure is equal to 2 times 10 raised to the power 5 Newton per meter square. So basically you have your data given and you are looking for what your final volume. So what do? You know that I forgot to mention, so if V is inversely proportional to 1 over P, therefore your P equals multiply. So if you put a constant, you have that V is equal to K times 1 over P, where K is your constant. That means it does not change. So K is equal to what? PV. That is, therefore your P1 times your V1 is equal to what? Your P2 times V2 is equal to what? Your P3 times V3. So that is what this one is saying, that once you multiply your P1 and your V1, it must give you your P2 times your V2. So that is what we'll do here. So knowing that, we now see, therefore, using Boyle's law for our excellence, writing this will give you a bonus. Using Boyle's law it first of all tells the examiner that you know which law you are using. P1 V1 is equal to what? P2 V2. So what is my P1? 1 times 10 raised to the power 5 times my V1 times 200 is equal to P2, which is 2 times 10 raised to the power 5 times what? V2. So we are looking for V2, so V2 is equal to, we divide both sides. Divide both sides by 2 times 10 raised to the power 5 divided by 2 times 10 raised to the power 5. So this are left with V2 here. Then 2 here 1, 2 here 100. So 1 times 10 to the power 5, 1 times 10 to the power 5, they cancel out. So what are you left with? So we are left with V2 equal to what? 100. What is your unit? Take note, cm cube. So that is your answer. So now it's very simple to check. You can just say what happened. Your volume was 200 cm cube and your pressure was 1 times 10 to the power 5. What happened to your pressure? It's increased. So since my pressure increased, my final pressure is higher than my initial pressure. So it's increased. Therefore, my volume will what? My volume will decrease. So you can see your volume decreased from what? From 200 to 100 cm cube. So basically that is it for your Boyle's law. So look at another exercise, another example. It seems that JAMB love, they don't love numbers. They want you to understand the principle. So you can see a question. Let's look at this. Example 2. Let's call this example 1. So for example 2, you can see if the pressure exerted by a given mass, if the pressure exerted by a given mass of gas is doubled, find the new volume of the gas, given that the initial volume was V. So this can just be the question. Then you have options A and the rest. So let's look at how to solve the question. So if the pressure exerted by a given mass of gas is double, find the new volume of the gas given that the initial volume was V. So solution. What was given in this question? Let's see. So we have our V1, that is our initial volume. We are told that our initial volume was what? Was V. So initial volume is equal to V. Then our final volume is what we are looking for. Final volume is unknown. So let's put full question mark there. Our initial pressure did not give us our initial pressure, but they said what? The final pressure was double of the initial. So what do? They say the pressure exerted by a given mass of gas is double. That means our P2 so this is initial pressure. So they say it was this P1 initial pressure. Is that our P2? Our P2 is equal to what? 2 P1. I see it because they told that if the pressure exerted by a given mass of gas is double, so our final pressure is what? Equal to P1. That is our final pressure. So what do we do here? What we simply do is they have given us everything we need. And so remember that P1 V1 using Boyle's law. P1 V1 is equal to P2 V2. So therefore P1 times what? V, which is our V1. So P1 times V is equal to what? P2 times what? V2. But remember that your P2, so we now say substitute 2P1 for P2. So remember that we say what? P2 is equal to 2P1. So therefore we can now say P1 times V is equal to what? 2P1 times V2. So what will be our V2? V2 divided both sides by 2P1 divided by 2P1. So P1 will cancel P1, 2P1 will cancel 2P1. So you are left with what? V2 is equal to 1 over 2V. So that is the answer. So your V2 will be half of your V. So it's understandable. If you double it, if you double your pressure, you have your volume. If you triple your pressure, you get 1/3 of your volume. If you increase your pressure by times 4, you get 1 over 4 or quarter of what the volume, and so on and so forth. So inverse proportion. So what that simply means is, if you increase pressure by 2 over 5, therefore you will decrease your volume, and that decreasing will be by what? By 5 over 2. So that is simply what it is. So okay, so that's it for your Boyle's law. We'll be moving on to the next, which is your Charles law. See you in the next video.